This is the last day of Chapter 12 notes, and we're going to talk about scope of inference and blocking. The scope of inference refers to the type of inferences, i.e. conclusions, that can be drawn from a study. The type of inferences we make, inferences about the population, inference about cause and effect, are determined by two factors in the design of the study: how subjects were selected from the population and how the subjects were assigned to groups. So this little box is kind of helpful. Okay, if you select subjects from the population at random and you randomized your subjects into groups, so randomly selected, say, who got caffeine and who didn't, then you can make an inference about the population and inferences about cause and effect. Okay. However, if you don't randomize your selection, just your allocation of the treatment, you can make inferences about cause and effect, but only from those people in the study. And then it's kind of vice versa this other way. Again, let's see, if you randomize from the population, but not your groups, then you lose the cause and effect. So some observational studies are in this because you may randomize who you're looking at and who you're studying from the population, but if you don't randomize who gets what, then you can only make inferences about the people, but not cause and effect inferences. Okay? And then the last, if you don't randomize in any way, you can make no inferences about the population, and you can't say anything about cause and effect. This is almost, it's not useless, but it's just some observational studies are here. It's where we go, we think this is happening, but we really can't make any inferences about it at all. Okay, this might be like the ADHD study we read before. So I want you guys to look that over again. And then what I want you to do is to read these 4 little excerpts about a dentist. Okay, so read case 1, 2, 3, and 4, and decide if it's going to be, you can make these inferences, 1, 2, 3, or 4. However, don't just put the numbers. Please tell me, I may make inferences about the population and about cause and effect, or not about the population, but I can do cause and effect. Tell me about that for each one and come to class with that. Okay? But we're going to skip about that because we will talk about it in class. And let's talk about that last element of design, which is blocking. Okay? Blocking is when subjects are divided into homogeneous groups, i.e. groups that are based on the same characteristic, okay, of some extraneous variable, and then separated into different treatment groups. What if men, for the question is, what if men react differently to caffeine than women? Okay, if we did our regular study without taking that into account, it would add more variability, which would make it harder to see the differences in the results. And that goes back up to the picture we did up here. Okay, we might get results like this, where they're fairly spread out, and it's harder to see that this one had a lower rate than this one. Okay, so how can we eliminate this source of variability? Well, one, we could only do one gender in the study, but then we can only make inferences about that gender. Okay, so that's a problem. The other thing we could do is this. We can make sure there is a representative number of women and men in each treatment group. For example, let's say we had 20 women and 30 men that volunteered for the study. Then we could split it up and make sure that we have 10 women in the caffeine group and 10 women in the no caffeine group, and then split the men as well, so we have 15 men in the caffeine group and 15 men in the no caffeine group. We do this by grouping by gender. So saying we put all of our men over here and all of our women over here, and then assign half the men caffeine randomly. Okay, we got to do it by simple random sample, and half the men no caffeine. Similarly, simple random sample, half the women caffeine and half the women no caffeine. Okay, so that is how you block. Blocking in experiments is similar to stratification and sampling. Basically, it's the exact same thing. We group by similarity and then take a simple random sample for stratification. In blocking, we group by similarity and then assign treatments. And I shouldn't have used simple random sample here. I should have said just randomly assign. But it's so similar, notice that I mix them up. Randomly assign. Randomly assign. Okay. Blocks should be chosen like strata. The units within the block should be similar, but different than units in other blocks. You should only block when you expect that the blocking variable is associated with the response variable. What are some extraneous variables we can block for? We talked about these before. Okay, we could have done age, weight, initial pulse rate, tolerance to caffeine. Okay, things that we could measure in our people and then put them together in groups by how they respond. We should try to make the blocks as small as possible. Ideally, the size of the block should be the same as the number of treatments. Okay, and I'm highlighting this, you should highlight this. For example, if there are 3 treatments, then there should be 3 subjects in each block. If each block only has 2 subjects, then the subjects are called a matched pair. Okay, how can we assign treatments in a matched pair? Maybe we could call person 1 heads and person 2 tails and flip a coin. Okay, anything that's going to be random with 2 people. If you do not use blocking when dividing the subjects, the result is a completely randomized design. Okay, but again, that may have more variability. If you incorporate blocking into your design, it is called a randomized block design. Every subject is assigned to a block based on some characteristic, and the members of the block are randomly assigned to different treatments. And honestly, this vocab word is like a little bit too much. You just need to know what blocking is. Okay, guys, that's it. I'll see you in class. Make sure you do the cases.